All right, let's go ahead and talk about this activity. Okay. All right, so for that first question, there's two coordinates. Some of you drew a line through it. Some of you took the, boring, right? A line. Some of you drew a parabola. Could I have done that? I mean, technically, yeah, but okay. Is everything okay? Okay. Could we have drawn something like that? Okay. No matter what we draw, every single one of those graphs have a what for number 2? An x-intercept. And why do we have an x-intercept?
Because the x-axis is in between the 2 points.
The x-axis is in between the 2 points. So if we have a continuous function, we're going to hit it. Okay? Now, what about the y values? So we have to hit the x-axis. Okay? You have a list of number 3. Which y values do we have to go through no matter what? Okay? Negative 1 and positive 2. All of the y values between negative 4 and 3, you're going to have to hit because we have a continuous function. And that's what the intermediate value theorem is saying. Okay? So you drew some graphs on the back of discontinuous functions, right? Okay? So you can see that with your discontinuous functions, you don't have to hit the x-axis necessarily. You don't have to hit all of the values in between. I see some people who drew the greatest integer function. There's lots of y values you don't hit in between if you have the greatest integer function. Okay? So this is our intermediate value theorem. And yes, I know it's wordy. I'm going to have a different one for you to write down. But could somebody tell it to me in their own words? I've already kind of said it.
It's like if you have like 2 points and it's a continuous function, then you're going to hit every y value between those 2 points.
That is exactly right. Okay? If you have 2 coordinates on a continuous function, then in between those 2 coordinates, you're going to hit every y value in between. Okay? And that's pretty much, if you want to write, I mean, look, this is like exactly what I have up here, Max. Good job. So in your notebooks, if you want to write this in your notes, this would be a good place for it. We're still going to talk about number 7. You're not getting out of it. But this is the intermediate value theorem. You don't need to write what's in the blue. Just what's up there in that buff colored box. Okay, and as you're writing this, I want you to think about some real life examples. Okay? Real life examples of the intermediate value theorem. By the way, I bought my candy for those homework completion people. Means if you do all of your homework, then on this chapter test, you get cool.
That's really good.
You have an example?
No, I was telling them my flawless record of homework and improved out.
Oh, yeah, okay. Who has a real life example? Dylan.
Of watermelons I have, and the amount of money I make by selling said watermelons.
Okay, what?
I'm going to sell each watermelon for like $10. I have a bunch of watermelons. So it's like just a silk. And then it's exactly.
Okay, but what about like 5.3 watermelons?
Okay, wait, that.
I mean, you're on the right track.
Escalators. You go along an escalator and you can hit every height on your way up.
Oh,
If you
that's
cross
not a
over,
bad one.
if you cross over jump, you have to hit every distance as well.
Okay, when you cross a river, you're, okay.
Running across a football field.
Okay, running across a football field, you're gonna be at every yard mark. What about, like, did you start out as a 5'8" individual, Brayden? That's how you run.
5'9".
Did you start out as a 5'9" individual? No, you probably started out at like 20 inches long, right? But as you've grown, you've hit every height in between. You might not have measured yourself every single day of every single year. But when you grow, you hit all the heights that are in between where you started, maybe 20 inches, to where you are now, 5'2". Okay?
That's a really good example. There's like not an example I can beat that this
Well, you know, I saved the best for last.
teachers.
He wants extra credit.
Maybe my escalator was pretty good.
We're gonna do 2 examples.
I think hers is just a touch better.
Ethan's trying to
Yeah.
Except for when you put shoes on.
Okay, barefoot height.
Max,
heels.
Yeah.
What's your counterexample heels?
Would you believe me that my son's supposed to be 6'2"?
How old is he?
Well, right now he's 6, but they're projecting him to be 6'2".
Don't believe it. My doctor
I told you that's what
told
they
me
think.
I could be 6'1", and now it's like, oh, you're only gonna be 5'10".
That's because you had caffeine.
Some people hit a growth spurt in college, men.
Oh.
Some males hit a growth spurt in college.
I had a growth spurt in seventh grade. My dad had that in freshman year of college. He was from like 5 to like 6.
See, there's hope for you. Her dad grew like 6 inches his freshman year of college. All right, here's our example. Let's get focused. We're getting off track here. And if I'm God next year on this day, then next year's class gets to hear all of our ramblings. I record this, remember? Hello, future calculus students. Just kidding, I won't be on this day. All right, so we have an interval of -2 to 1. Did you write that down?
Yes.
And are you writing down that f of x is x to the 4th minus 2x squared plus 3x? Okay, so first of all, I'm asking us to prove that f of x has a 0. Well, I have an interval in terms of x. What would we hope to find about
One value below the x-axis and one above.
Okay, we need a y value below and a y value above the x-axis. And if we do, then we're guaranteed to cross the x-axis like the picture you had in number 1, right? So, how could we determine if we have a point below and a point above?
Plug in -2 and 1. I'm so good at this.
If you're a female, please calculate f of -2. If you're a male, please calculate f of 1. I'm just splitting the class in half.
It's still recording. How you doing? You're doing one. You're sitting there. We're doing F1. Braden's trying to be still. He's not trying to.
Not calculus.
Wait. Okay. 2/3 is 8 to everything. Okay, and then
About
no, it's negative 8.
that was somebody.
My
I
bad.
went back and
Because
listened to
like
those
negative
numbers.
2 squared is 4 times negative 2. I was like listen.
Okay, did I give -2 to the females?
Yes, ma'am.
All right. Kinley, what'd you get?
2.
2?
Yep.
Woo.
I for sure
Okay.
said
F of 1, Trenton, what'd you get?
2.
Really?
Yeah.
Don't you wanna-
1 minus 2 plus 2.
Awesome.
Is that wrong? Is that not supposed to be Or are you supposed to have
1 to the 4 is 1.
Discontinue.
Plus 3. Negative 2 times 1 is 2. 1 minus 2. That's negative 1. Plus 3 is 2.
Well, this isn't gonna work, is it?
Actually, I don't know.
Does it dip down though?
Well,
We can't.
I picked a bad example. Hold on.
We just changed the last one.
Matthew said I about it.
I saw Instagram every day. I don't see well ever. And I saw it like 3 of them.
Okay.
Like, oh my
How
God.
about -1?
It's like the whole year too.
What happens if we plug in -1?
Oh, I gotta choose.
Negative 4.
Okay. So that must have been what I meant. All right, here we go. Change it from -1 to +1.
Wait.
Wait,
You
no.
put the negative 1 in for
Negative 2 to negative 1.
It's just one of those.
No, it works. It
Wait,
works.
it's okay. We can restart.
We can restart.
Everyone restart.
I wanted -1.
Okay.
Okay.
That was,
And f of -1 is,
Negative 4.
Negative 4.
okay. F of 1 is
2.
2.
I've got it. You can go.
So, since f is continuous, and 0 is in between f of -1 and f of +1, then what? F of c has to equal 0 somewhere on the interval, right? Okay, so since f is continuous and 0 is in between our two function values, then we equal 0 somewhere where c is between -1 and 1. Where does that occur?
0.
It occurs at 0.
Oh yeah. 0 minus 0.
Well, we could solve for it, yeah, by setting this equal to 0 and solving for it. I could ask you to go that extra step, yeah. But this was just prove to me that there is a 0. Okay, it's obvious because I picked that example. Great. And maybe I didn't mean for that to be an x. I'll have to go back and change that. Okay. So let's do a different example very quickly. Not about an x-intercept, but about there we go. So write that all down. F of x equals x squared minus x plus 4. Our intervals from 0 to 5. And f of c, I want to prove that somewhere we equal 10.
Will we always have to like find where it is, or?
So this is saying find the C value. So we will find it. Yeah.
But do we always have to, like on the other one? Is it just like?
So you'll just have to read. So it either says verify or find it. Okay. Okay. So first of all, what is f of 0?
4.
What's f of 5?
24.
Oh, good. Okay. So f is continuous because we have a parabola, right? And we know that 10 is in between f of 0 and f of 5. Okay? So somewhere along here, f of c is going to equal 10, where c is between 0 and 5, right? Now, if I wanted you to actually calculate what c is, what would we have to do?
You have to plug in 10 for f then.
Yep. I'll remind you that you do need to set yourself equal to 0 before you solve. So first I have it set equal to 10. You got to move that 10 over so you can do any sort of algebra. What does that factor to?
X minus 3 and x plus 2.
Okay, so we get values of 3 and negative 2. Which one do I care about? Okay, our C value is 3. Negative 2 is not in the interval, so I don't really care about it. Okay, you have homework tonight. Do your homework. Pep rally scheduled tomorrow. Anybody leaving early? Okay, if you leave early for the pep rally, you'll just need to watch the video of my notes sometime after the pep rally. Okay.